Okay, good to see you again. This is our last video on LeChatelier's principle. This time we're going to be talking about pressure, and we'll briefly talk about catalyst as well. Talking about pressure, I think, is one of the most difficult topics when it comes to LeChatelier's principle. But here's the idea, and then we'll try to get into the why of it afterwards. So, first thing you need to know is pressure really only affects chemicals or substances that are in the gas phase. And so, when we do this type of problem, we really need to look at, are the molecules in the reaction in the gas phase, and how many molecules? Here's what LeChatelier's principle says. If you raise the pressure of a group of gas particles by decreasing the volume, then the container or the reaction will shift in the direction of fewer gas molecules to reduce the pressure. Why is that? Well, gas molecules cause pressure. So if we increase the pressure, what's the opposite? Decrease the pressure. How do you get there? You go to the side where there are fewer gas particles available. So let's take an example. In this first problem, it says the container of the following reaction has its volume suddenly reduced by half. Which way will the reaction shift to compensate? Well, here's what I want to think about. I want to think about what's really going on in the problem. And so to do that, I'm going to draw, I can't draw very well, but I'm going to draw a container. And inside of that container, let's put some particles of different types and different colors. So let's say that we have some PCl3. Let's say that we have some, and we'll say, okay, this is PCl3. Let's say that we have some Cl2. That's yellow. You can barely see it, but it's there. And let's say that we have some PCl5. And for PCl5, we'll put 3 dots as well. Okay. And then we go along and we reduce the container size. So the volume is now smaller than it was. But we still have the same number of particles and initially the same types of particles involved. And we're no longer at equilibrium when we do that, because essentially what we've done is we've changed concentration. Now, the truth is, you've changed the concentration of everything, not just the reactants, not just the products, but both of them have been changed by changing the volume of the container. Why? Because concentration is moles over liters, right? Well, if I've reduced the number of liters, then concentration of everything is going up. But that's going to have an impact on one side of the reaction more than the other. How do you know? Well, you know by looking at the total number of gas particles on each side of the reaction. So if I look at PCl3, that's one gas particle. Cl2, that's one gas particle. PCl5, that's one gas particle. In other words, on the right side of this reaction, we have one gas molecule on the right. But on the left side of this reaction, we have two total gas molecules or moles, either way. So increasing the concentration of everything actually increases the concentration on the reactant side more because there's more gas particles to begin with. So if I increase the pressure on this side, and notice I'm going to put I should say, increase the pressure of the whole thing. I'm not doing one side or the other. It's the whole system where the pressure is going to increase. LeChatelier's principle says the reaction will shift to the side with fewer gas molecules. Well, that's to the right. So I will start making more PCl5 and I will lose Cl2 and PCl3. Again, why is that? Because overall, that means I'm reducing the total number of gas particles. And so that will reduce the pressure, which was increased. Let's look at the second question. Second question, the container holding the following reaction has its volume increased. Which way will the equilibrium shift? This is actually a really interesting problem. So essentially, this is what they're saying. I don't want to draw all the molecules again, but we're going from a container that looks like that to a container that looks like this. It's bigger. So the pressure goes down. I'm going to draw my stress arrow right over here to the side. Usually when we're talking about pressure, I just do the stress arrow to the side somewhere. So pressure is going down in this container. Well, LeChatelier's principle says the reaction will shift to the side with more gas particles. That will increase the pressure. It'll make the pressure go back up. But this is an interesting problem because look at how many gas particles we have. We have one there, we have one here, and we have a total of 2 right here. So in other words, I'm going from 2 gas molecules on the left to 2 gas molecules on the right. But the principle says the reaction should shift to the side with more gas molecules. There isn't a side with more gas molecules. So what will happen? The answer is a big nothing. Nothing happens. There's no effect because the reaction isn't going to favor one side over the other because there are the same number of gas particles on both sides. Finally, let's look at what happens when we don't change the container size, but we just add some other gas that's not reacting, like neon, a noble gas. So in this particular case, my reaction vessel stays the same size, but I'm just adding some other gas in there. Well, by adding more gas particles, the pressure is going to go up, right? Pressure increases. But I'm not changing the moles or the liters of any of these other 3 gas particles. Long story short, if the way you change pressure is by changing the number of or the type of gas that's introduced, a non-reacting gas like neon, it's not going to shift at all. So again, there's no effect when you add some sort of outside gas that isn't reacting. Okay, very important. This video has already gotten pretty long, so I'm going to go through catalysts really quickly and give you the answer straight off the bat. No effect. Why not? Well, what does a catalyst do? Catalysts are known for speeding up reactions, but a catalyst isn't going to favor the forward reaction more than the reverse reaction. So typically, when you add a catalyst to a reaction, it makes the whole reaction faster, but it's not going to shift the reaction left or right. There's going to be no effect on the overall equilibrium position. Okay, let's come back to class.